and the uniformity of the temperature in all parts of the mass is desirable, as showing that all parts are fermenting evenly. The cacao is usually shoveled from one box to another every 1 or 2 days. The chief object of this operation is to mix the cacao and prevent merely local fermentation. To make mixing easy, one ingenious planter uses a cylindrical vessel which can be turned about on its axis. In other places, for example in Java, the boxes are arranged as a series of steps, so that the cacao is transferred with little labor from higher to the lower. In San Thomé, the cacao is placed on the plantation direct into trucks, which are covered with plantain leaves, and run on rails through the plantation right into the fermentary. Some day some enterprising firm will build a fermentary in portable sections easily erected, and with some simple mechanical mixer to replace the present laborious method of turning the beans by manual labor. The general conditions for a good fermentation are: 1. The mass of the beans must be kept warm. 2. The mass of the beans must be moist but not sodden. 3. In the later stages there must be sufficient air. 4. The boxes must be kept clean. Changes during fermentation. No entirely satisfactory theory of the changes in cacao due to fermentation has yet been established. It is known that the sugary pulp outside the beans ferments in a similar way to the other fruit pulp, save that for a yeast fermentation the temperature rises unusually high, in 3 days to 47 degrees Celsius, and also that there are parallel and more important changes in the interior of the bean. The difficulty of establishing a complete theory of fermentation of cacao has not daunted the scientists, for they know that the roses of philosophy are gathered by those who can grasp the thorniest problems. Success, however, is so far only partial, as can be seen by consulting the best introduction on the subject, the admirable collection of essays on the fermentation of cacao, edited by H. Hamel Smith. Here the reader will find the valuable contributions of Fickendey, Loew, Nichols, Pryor, Schulte Imhoff, and Sack. The obvious changes which occur in the breaking down of the fruity exterior of the bean should be carefully distinguished from the subtle changes in the bean itself. Let us consider them separately. A. Changes in the pulp. Just as grape pulp ferments and changes to wine, and just as weak wine, if left exposed, becomes sour, so the fruity sugary pulp outside the cacao bean on exposure gives off bubbles of carbon dioxide, becomes alcoholic, and later becomes acid. The acid produced is generally the pleasant vinegar acid, but under some circumstances it may be lactic acid or the rancid-smelling butyric acid, kismet. The planter trusts to nature to provide the right kind of fermentation. This fermentation is set up and carried on by the minute organisms, yeasts, bacteria, etc., which chance to fall on the beans from the air, or come from the sides of the receptacle. One yeast cell does not make a fermentation, and as no yeast is added, a day is wasted whilst any yeasts which happen to be present are multiplying to an army large enough to produce a visible effect on the pulp. Any organism which happens to be on the pod, in the air, or on the inside of the fermentary will multiply in the pulp, if the pulp contains suitable nourishment. Each kind of organism produces its own characteristic changes. It would thus appear a miracle if the same substance were always produced. Yet, just as grape juice left exposed to every micro-organism of the air generally changes in the direction of wine more or less good, so that the pulp of cacao tends, broadly speaking, to ferment in one way. It would, however, be a serious error to assume that exactly the same kind of fermentation takes place in any two fermentaries in the world, and the maximum variation must be considerable. As the pulp ferments, it is destroyed, It gradually changes from white to brown, and a liquid, sweatings, flows away from it. The sweatings taste like sweet cider. At present this is allowed to run away through holes in the bottom of the box, and no care is taken to preserve what may yet become a valuable by-product. I found by experiment that in the preparation of 100 count of dry beans, about 1½ gallons of this unstable liquid are produced. In other words, some 7 or 8 million gallons of sweatings run to waste every year. In most cases only small quantities are produced in one place at one time. This, and the lack of knowledge of scientifically controlled fermentation, and the difficulty of bottling, prevent the starting of an industry producing either a new drink or a vinegar. The cacao juice, or sweatings, contains about 15% of solids, about half of which consists of sugars. If the fermentation of the cacao were centralized in the various districts and conducted on a large scale under a chemist's control, the sugars could be obtained, or an alcoholic liquid or vinegar could easily be prepared. The planter decides when the beans are fermented by simply looking at them. He judges their condition by the color of the pulp. When they are ready to be removed from the fermentary, they are plump and brown without, and juicy within. B. Changes in the interior of the bean. What is the relation between the comparatively simple fermentation of the pulp and the changes in the interior of the bean? This important question has not yet been answered, although a number of attempts have been made. As far as is known, the living ferments, microorganisms, do not penetrate the skin of the bean, so that any fermentation which takes place must be promoted by unorganized ferments, or enzymes. Mr. H.C. Brill found raffinase, invertase, cassase, and protase in the pulp, oxidase, raffinase, and sesase, and emulsin-like enzymes in the fresh bean, and all these 6, together with the diastase in the fermented bean. Dr. Fickendey says, "The object of fermentation is, in the main, to kill the germ of the bean in such a manner that the efficiency of the unorganized ferment is in no way impaired." From my own observations, I believe that forastero beans are killed at 47° Celsius, which is commonly reached when they have been fermenting 60 hours, for a remarkable change takes place at this temperature and time. Whilst the microorganisms remain outside, the juice of the pulp appears to penetrate not only the skin, but the flesh of the bean, and the brilliant violet in the isolated pigment cells becomes diffused more or less evenly throughout the entire bean, including the germ. It is certain that the bean absorbs liquid from the outside, for it becomes so plump that its skin is stretched to the utmost. The following changes occur. 1. Taste. An astringent colorless substance, a tannin, or a body possessing many properties of a tannin, changes to a tasteless brown substance. The bean begins to taste less astringent as the tannin is destroyed. With white Criollo beans, this change is sufficiently advanced in 2 days, but with purple Forastero beans it may take 7 days. 2. Color. The change in the tannin results in the white Criollo beans becoming brown, and the purple Forastero beans becoming tinged with brown. The action resembles the browning of a freshly cut apple, and has been shown to be due to oxygen, activated by an oxidase, a ferment encouraging combination with oxygen, acting on the astringent colorless substance, which, like the photographic developer, pyrogallic acid, becomes brown on oxidation. 3. Aroma. A notable change is that substances are created within the bean which, on roasting, produce the fine aromatic odour characteristic of cocoa and chocolate, and which Messrs. Bainbridge and Davies have shown is due to a trace (0.001%) of an essential oil, over half of which consists of linalool. 4. Stimulating effect. It is commonly stated that during fermentation there is generated theobromine, the